So here I'm going to be talking about principles of chance deference. And really roughly, what a principle of chance deference says is, given that the objective chance of P is n%, you should be n% sure that P. I think principles like this are very plausible, but I think that they face two kinds of problem cases. In the first place, it looks like these kinds of principles give bad advice when P is something that's both a priori and contingent. And in the second place, I think that they give bad advice in cases where you suffer from a certain kind of de se uncertainty, in particular in cases where you've lost track of what time it is. What I'm going to do here today is I'm going to review these problem cases and then propose a revision to standard principles of chance deference that's going to allow us to deal with them. And in rough outline and slogan form, what that revision is going to say is you shouldn't defer to the objective chances about whether P. Instead, you should defer to the objective chances about whether your thoughts are true, given the locations at which you're entertaining them. So I'm going to start off by reviewing a kind of standard principle of chance deference that I'm going to attribute to Lewis, raise the two problems for it that I discussed earlier. And then in section 2, I'm going to propose a revision to that principle of chance deference. I'll call it a de se principle of chance deference. And then in section 3, I'm going to show that that principle has a surprising consequence for Adam Elga's Sleeping Beauty puzzle. Let me start with Lewis's principle of chance deference. So the principle I'm going to call Lewis's principle of chance deference isn't the one that Lewis calls the principal principle that people may be more familiar with, but it follows from the principal principle together with conditionalization. And in a lot of applications and discussions, this is the principle that people appeal to. It says, for any thought P, any number n, and any time t, your credence in P, given that the time t chance of P is n%, should be n%. Or at least it should be n%, so long as you don't have any information or any evidence that is inadmissible for the time t. By the way, here I'm using the word thought just stipulatively refer to whatever the arguments of your credence function happen to be. And I'm using the word inadmissible the way that Lewis used it. So for information or evidence to be inadmissible is for it to be about times that are in the future. So for evidence to be time t inadmissible is for it to be about times after t. So some standard examples of inadmissible information or inadmissible evidence is evidence about what a time traveler tells you, or information that comes to you by way of a crystal ball or something like that. So in this section, I'm going to try to persuade you that Lewis's principle runs into two kinds of problems. In the first place, it gives bad advice how to defer to the chances about a priori knowable contingencies. And this kind of problem has been noted before by people like John Hawthorne, Maria Lassen and Arnio, Nathan Salmon, and Ben Nolan. And in the second place, that when you've lost track of what time it is, Lewis's principle gives some bad advice. This second problem is, I believe, to the best of my knowledge, not been discussed before. So let's start with the first problem. Suppose that we're going to flip a coin, and before we do so, we introduce a name, uppy, for whatever side of the coin actually lands facing up. So if the coin actually lands heads, then uppy is heads. If the coin actually lands tails, then uppy is tails. Then consider the thought, the coin lands on uppy. So this thought is contingent. It's contingent because suppose the coin actually lands on heads, then what you says is that the coin lands on heads, and that's contingent. It could have landed on tails. Or suppose that the coin lands on tails, well then uppy is tails, and that's contingent because the coin could have landed on heads. It's contingent, but nonetheless it's a priori. Given the way that the name uppy was introduced, you can know a priori that if the coin lands any way at all, it's going to land on uppy. But now consider what Lewis's principle says about that thought, the coin lands on uppy. If we let t be u and we let n be 50, the principle says, well, your credence that the coin lands on uppy given that the objective chance of the coin landing on uppy is 50%, should be 50%. But notice that antecedent, that the chance that the coin lands on uppy is 50%, you know that for sure, because uppy is either heads or it's tails. And if it's heads, then the chance that the coin lands on uppy is 50%, because the chance that the coin lands on heads is 50%. If uppy is tails, then the chance that the coin lands on uppy is just the chance that the coin lands on tails, which is 50%. So you know that for sure. And if you know something for sure, then you can just ignore it whenever it shows up on the right-hand side of a conditional credence like this. So Lewis's principle says that you should be 50% confident that the coin lands on uppy, or your credence that the coin lands on uppy should be 50%. But this looks implausible because it's, after all, a priori know that if the coin lands anyway at all, it's going to land with uppy facing up. So it looks like you really should be much closer to 100% confident that the coin lands on uppy and not down around 50%. That's the first problem. Second problem. Imagine that you've lost track of what day it is. So you think it could be Monday, it could be Tuesday, and you're 50% confident in each of those. But you know for sure that today's chance of the mud skipper winning the race. So W here is just mud skipper wins. So you know for sure that the objective chance of mud skipper winning the race today is 75%, and that yesterday it was 25%. So then it could be Monday, in which case the objective chance of mud skipper winning today on Monday is 75%, and on Sunday it was 25%. Or it could be Tuesday, in which case the Tuesday chance of mud skipper winning is 75%, and the Monday chance was 25%. Now think about the Monday chance function. So in your state of uncertainty about whether it's Monday or Tuesday, you think the Monday chance of mud skipper winning might be 75%, might be 25%. Then Lewis's principle says, well, your credence that mud skipper wins, given that the Monday chance is 25%, should be 25%, and your credence that mud skipper wins, given that the Monday chance is 75%, should be 75%. And you know for sure that the Monday chance is 25%, if and only if today is Tuesday. And if you know that one thing is true if and only if the other is, then those two things are intersubstitutable in your credence function. So we can replace the thought that the Monday chance of mud skipper winning is 25% with the thought that today is Tuesday. And likewise, you know for sure that the Monday chance of mud skipper winning is 75% if and only if today is Monday. So that's intersubstitutable. Those two thoughts are intersubstitutable. So Lewis's principle says that given that it's Tuesday, you should be 25% confident that mud skipper wins, and given that it's Monday, you should be 75% confident that mud skipper wins. And that implies, via the law of total probability, that your credence that mud skipper wins should be 50%. It should be somewhere between 25 and 75%. And since we stipulated that you think it's 50% likely to be Monday and 50% likely to be Tuesday, it should be exactly 50%. But this also looks implausible because, after all, you know for sure that today's chance of mud skipper winning is 75%. You know that right now the chance of mud skipper winning is 75%. And given that, it looks like you should be 75% sure that mud skipper wins. You shouldn't be down around 50%. Well, maybe I made a mistake on the last slide. Maybe I shouldn't have been allowed to apply Lewis's principle to the Monday chances, because maybe you have some Monday inadmissible information. And if you have Monday inadmissible information, then Lewis's principle won't say anything about how you should Monday chances. I have a hard time making sense of that idea. And the reason is that given Lewis's criterion of admissibility, what it is for you to have inadmissible information is for you to have information about times after Monday. But nothing about this case requires us to suppose that it's Tuesday. So let's just suppose that actually it's Monday. And if that's the case, it's difficult to see how you could have come by information which was about times after Monday. There aren't any time travelers about. There aren't any crystal balls. So it looks to me like, at least given Lewis's criterion of inadmissibility, this is a case where you don't have any inadmissible information. So just to summarize what I've said, I think that the principle that follows from Lewis's principle together with conditionalization runs into two kinds of problem cases. Issues with a priori knowable contingencies, if the coin lands on uppy, and it looks like it gives bad advice in cases where you've lost track of what time it is. In this section, I'm going to present and defend a De Se revision of Lewis's principle of chance deference, which is going to handle both of those problem cases that we just saw. And to start out, I want to think not about how to defer to the objective chances, but think about how you would defer to some other kind of expert like your doctor. So, a naive principle of doctor deference would say something like, well, given that my doctor is in% sure of P, I should be in% sure of P. Or my credence in P, given my doctor's credence function. So this script D here I'm using for the definite description of my doctor's credence function, and then B is just some particular probability function. My credence in P, given my doctor's credence function, should be whatever probability my doctor gives to P. That looks good in a lot of cases, but I think that this principle gives bad advice about how to defer to your doctor when P is a De Se thought. So let P be the De Se thought, I am sick. And then it says, well, given that my doctor is in% confident in I am sick, I should be in% confident in I am sick. But that looks like bad advice to me. And the reason is that when my doctor entertains the De Se thought, I am sick, she entertains a thought which is true just in case she is sick. And when I entertain that De Se thought, I entertain a thought which is true just in case I am sick. And there's no connection at all between whether I'm sick and whether my doctor is sick. What I think the principles should want to say, at least in this particular case, is that I shouldn't defer to my doctor by setting my credence in I am sick equal to her credence in that same De Se thought. Instead, I should defer to her by setting my credence in I am sick to an appropriately chosen surrogate of I am sick. And in this case, the surrogate should be, for me, it should be Dimitri is sick. I should say, given that my doctor is in% sure that Dimitri is sick, I should be in% confident in I am sick. And what I'm going to do in this section is show how to take that kind of approach and generalize it across the board. So what I'm going to do is I'm going to introduce the notion of a location. So let my location, I'm going to use Greek letters, lowercase Greek letters for locations throughout. So let lowercase delta be my location. And then given the notion of a location, I'm going to go on to define a locational surrogate for a thought. So given a thought S, for instance, a De Se thought I am sick, and given a location delta, I'm going to define the locational surrogate of that thought. And in this case, the delta surrogate of S is just going to say that Dimitri is sick. And our principle is going to say in general that my credence in S, given my doctor's credence function, should be whatever probability my doctor gives to the delta surrogate of S. So that's the big picture plan. Let me start off by saying a little bit more carefully what I mean by a location and a locational surrogate. So I'm going to start with the notion of a thought which is purely De Se. A purely De Se thought is a thought which says something about who you are, about where you are, and what time it is, and it doesn't say anything else about the world. It doesn't say anything else about what the world is like beyond who you are, where you are, and what time it is. So for instance, today is Monday might be a purely De Se thought. I am Beyonce might be a purely De Se thought. You might have some worries about at least that second example, because you might think, well, the De Se thought I am Beyonce implies that Beyonce exists. And that's something about what the world is like beyond who I am, where I am, and what time it is. And I think that's strictly speaking correct. And in the paper, I'm more careful about this, and the way I define purely De Se thought there is in part going to depend upon the collection of thoughts that we start with, the kind of algebra or agenda of thoughts that you have in your credence function. And I'm going to define it in such a way that if you have thoughts about Beyonce not existing, then a purely De Se thought will be, if Beyonce exists, then I am Beyonce. But for now, I'm going to put those complications aside. Let's just treat today as Monday and I am Beyonce as purely De Se thoughts. Then what I'm going to call a location is a thought which is strong enough to settle the truth value of all of your purely De Se thoughts, and no stronger. So it doesn't tell you the truth value of any thoughts other than your purely De Se thoughts. So that's what a location is. Now take any thought, P, and take any location, call it lambda. And I'm going to define the lambda surrogate of P. What it's going to say, this is just sort of, this is the definition expressed roughly. The lambda surrogate of P, which I'm going to write P sub lambda, is a thought which is true so long as P expresses a truth for the person located at lambda. Or in other words, another way of saying the same thing, P sub lambda says that the thought P expresses a truth at location lambda. That's really rough. In the paper, I try to give a more careful definition of it. For now, let me just explain how that definition plays out in a kind of popular, familiar framework for thinking about De Se belief. So let me just presuppose a framework where you spread your credences over sets of centered possible worlds. So remember, I'm using the word thought stipulatively to refer to whatever the arguments of your credence function happen to be. So in this framework, the arguments of your credence function are sets of centered possible worlds, which I'm going to treat just as a pair of an ordinary possible world and a center. And the center might be something like a triple of a person, place, and time, or something like that. And then, in this framework, de dicto thoughts correspond to, the strongest possible de dicto thoughts, which we can call worlds, correspond to the columns of this matrix. And locations, which are just kind of the strongest possible De Se thoughts, those correspond to the rows. So each of these rows is a location, and each of these columns is a world. And then a thought is just some way of sort of saying, well, a thought will just include some centers and not others. So we can specify a thought by saying which centered worlds it's true at and which it's false at. So here's a thought. It's true here and here and here and here and here, and it's false everywhere else. So together, if we take that thought and we take a particular location, say the second row of the column, then the locational surrogate of this thought is going to be one which is true anywhere in this matrix, so long as the thought is true, or it's going to be true in any column of the matrix, so long as the corresponding entry in the second row is true. Another way of thinking about that is I'm just going to duplicate the pattern of truth values that I have in the second row everywhere else. So in W1, in order to see whether the locational surrogate of the thought is true, I just ask, is it true at the location C2? It's not, so it's not true anywhere in W1. And in W2, it doesn't matter where I am, I ask myself, does this thought express a truth at the location C2? It does, so it's true everywhere in W2. In W3, it doesn't matter where I am, I ask myself, does this thought express a truth in the location C2? It doesn't, so it's not true anywhere in W3. And you would do the same thing for other locations. Basically, you just duplicate the rows throughout. But again, intuitively, what's going on here is you're just asking yourself, would this thought express a truth at that location? If it would, then its locational surrogate is true. If it wouldn't, then the locational surrogate is false. So going back to the example where I'm trying to show deference to my doctor, delta is my location. S sub delta is just going to say that the De Se thought, I am sick, expresses a truth when it's entertained by Dimitri at my location. So it just says that Dimitri is sick. And the proposal is that my credence that I am sick, given my doctor's credence function, should be my doctor's credence in the delta surrogate of I am sick. That is to say, it should be my doctor's credence that Dimitri is sick. So just that, I think there's another revision that has to be made, and the other, you may see it coming, the revision that has to be made concerns cases where I don't know who I am. I don't know what my location is. But even going this far is enough to solve the first problem that we encountered back in section 2. That was the problem with the contingent a priori. So just to refresh everyone's memory, we had a thought U, which said that the coin lands on uppy, where uppy is a name to refer to whatever side of the coin actually lands heads up. And Lewis's principle was giving bad advice in this case because it was saying that your credence in U should be equal to the objective chance of U. But now we're saying you shouldn't defer to chance about U itself, that thought. Instead, you should defer to chance about the lambda surrogate of U. The lambda is your location that we can just take to be known for now. Then what U sub lambda says is that your thought, the coin lands on uppy, expresses a truth. And it's important to recognize that even though the objective chance function is uncertain about whether the coin lands on uppy, because the objective chance function, it could be that uppy is heads, and then in that case, the objective chance function is uncertain about whether or not the coin is going to land on heads, or it could be that uppy is tails, and the objective chance function is uncertain about whether the coin is going to land on tails. Either way, the objective chance function is uncertain about whether the coin is going to land on uppy. But the objective chance function is certain that your thought, the coin lands on uppy, expresses a truth. No matter what the world happens to be like, it'll be the case that your thought, the coin lands on uppy, is going to express a truth. If the world evolves into one where the coin lands on heads, then uppy will refer to heads, and the coin lands on uppy will express a truth. If the world evolves into one where the coin lands on tails, then uppy will refer to tails, and your thought, the coin lands on uppy, will express a truth. So the objective chance that your thought, the coin lands on uppy, expresses a truth at your location, although the location isn't playing any role here, chance is 100% confident of that. And so the revised principle is going to say correctly that your credence that the coin lands on uppy should be 100% and not 50%. It'll say this, by the way, for any objective chance function. And so the principle of conglomerability will tell us that unconditionally, your credence that the coin lands on uppy should be 100%. And that kind of just falls out nicely. Once we've made the revision to the principle of chance deference that I proposed earlier. But it's worth noting that it could have been independently motivated. That kind of solution to the first problem could have been independently motivated. And so let me just quickly say something about how that independent motivation would have gone. I want to start off by sort of thinking about contingent a priori thoughts like the coin lands on uppy in terms of an epistemic two-dimensional framework of the kind endorsed by David Chalmers. So in this framework, consider this matrix now where the rows of this matrix correspond to things that might, for all I know, a priori be the actual world. So for all I know, a priori, the coin could land heads or it could land tails. And so in the columns, these are possibilities not considered as candidates for what might actually be the case, but these are possibilities considered as counterfactual or as possibilities. And the idea is, well, if the way to think about it, I think, is the rows of this matrix tell you the truth conditional content that the thought will have, depending upon what actually happens. If the coin actually lands heads, well, then the coin lands on uppy is going to express a thought which is true if the coin lands on heads and false if the coin lands on tails. On the other hand, if it actually turns out to be the case that the coin lands on tails, then the coin lands on uppie is going to express a thought which is true if the coin lands on tails and false if the coin lands on heads. Okay, so this is just a way of thinking about how sort of interesting contingent a priori thoughts like you are related to the truth conditional contents they express. And the first thing I want to note about this is that your credences are invested along the rows of this matrix. So you are 100% confident that the coin lands on uppie because you don't know whether you're in this first row of the matrix or the second row, but you do know that if you're in the first row, then you're in the first column. And you know that if you're in the second row, then you know you're in the second column. So when you're sort of dividing your credence amongst the possibilities, you're dividing them between the diagonal entries in the matrix. On the other hand, objective chance, at least as I'm going to be thinking about objective chance here, objective chance is just a kind of brute propensity for the world to evolve in one way or the other. So when we say that the objective chance of heads is 50%, we're just saying that it has a brute propensity to develop into a world in which the coin lands heads, and it has a certain propensity to develop into a world where the coin lands tails. So the objective chances aren't living along these diagonals. The objective chances are living along the rows. And the reason that contingent a priori thoughts are posing a problem for principles of chance deference is that the things to which you are attaching credence, the arguments of your credence function, are not the same as the arguments of the objective chance function. And what we need is some way of taking the kind of things that you attach credence to and cooking up a surrogate. Some appropriate surrogate that we can hand to the objective chance function. And in this case, I think the obvious natural surrogate is just the diagonalization of your thought. And that turns out to be the thought that thought is true. So one way of diagonalizing is taking the thought and taking the thought u and saying, for instance, u is true. That'll give us a proposition that is necessarily true. Even though it's contingent whether the coin lands on uppie, it's necessary that the coin lands on uppie is true. No matter what the world is like, the person who entertains that thought is going to be entertaining the truth, even though the truth they are thereby entertaining is contingent. So what we did when we sort of considered the case of the doctor and we introduced the idea of a locational surrogate, what we were doing was in part we were diagonalizing. And we were diagonalizing relative to a location, but the diagonalization is the important part of solving the first problem. And the diagonalization elements is a way of giving you and the objective chances a kind of common content on which you can coordinate your opinions. And I think that solution, it falls out wonderfully once we've made the revision to the principle that I think is called for due to De Se contents. But once we've done that, it also sort of neatly, nicely solves this problem with the contingent a priori. So let's remind ourselves where we were. I introduced the idea of a location. I introduced the idea of a locational surrogate. And I amended the principle of deference, the principle of doctor deference that we're working with. I amended it so it said that your credence that you are sick, given your doctor's credence function, should be your doctor's credence in the locational surrogate of I am sick. And that works really well if I know what my location is. But suppose I don't know. Suppose that I'm unsure whether I'm Dimitri or Beyonce. In that case, I think that the natural thing to say is, well, given that I'm Dimitri, so conditional on me being Dimitri, and conditional on my doctor being n% sure that Dimitri is sick, I should be n% confident in I am sick. And given that I'm Beyonce, and given that my doctor is n% confident that Beyonce is sick, I should be n% confident in I am sick. And I think, so that is to say, we should impose two constraints on our credence functions. The first is your credence in a De Se thought like I am sick, given that I'm Dimitri, should be the Dimitri surrogate, and given that I'm Beyonce, should be the Beyonce surrogate. where here I'm using beta as Beyonce's location. And in general, I think what we should say is for any expert E, given that the way to show deference to that expert is like this. Given that that expert's probability function is E, and given that you are at the location lambda, your credence in P should be whatever credence E gives to the lambda surrogate of P, or P sub lambda. So your credence in P, conditional on the expert's credence function being E, and you being at the location lambda, should be equal to whatever probability E gives to the lambda surrogate of P. Or in a slogan, you shouldn't defer to the expert about whether your thoughts are, well, so you shouldn't defer to the expert about your thoughts. You should instead defer to the experts about whether your thoughts express a truth given the locations at which you're entertaining them. Now, if we take that general sort of schema for showing deference to experts, and we apply it to the case of the objective chances, and we include a provision about inadmissible evidence, we get this. This says, so long as you don't have any time t inadmissible information, your credence in P, given that the time t chance function is CH, and given that you're located at the location lambda, should be equal to whatever probability CH gives, not to P, but to the lambda surrogate of P. In a slogan, you should defer to the chances about whether your thoughts are true, given the locations at which you're entertaining them. Now, I'm using this word inadmissible, and I don't want to use Lewis's analysis of what made thoughts inadmissible. Instead, I want to say that thoughts are admissible or inadmissible on a different basis. And to start sort of thinking through which thoughts we should say are admissible and which thoughts we should say are inadmissible, let me sort of note the following. If you assume prior conditionalizations, where by that I just mean that at every moment in time, there should be some prior credence function, C sub naught, such that your credence in any thought at that time is C sub naught updated or conditionalized on all of the evidence that you have at that time. Given that updating norm, it turns out that your credence in P, follows from prior conditionalization together with the principle of chance deference on the previous slide. So given those two assumptions, it follows that your credence in P, given that the objective chance function is CH and given that you're at location lambda, should be the probability that CH gives to the lambda surrogate of P, given the lambda surrogate of E. And I'm not going to go through and derive this here, but it's on the handout if you're interested in seeing how to derive that from prior conditionalization and the principle of chance deference that I'm proposing. So I said in the previous slide, when your total evidence is admissible, you should defer to chances. You should defer to the chances like this. So, your credence in P, given the chance function in your location, should be equal to the chance that CH gives to P sub lambda. But here I'm saying that that same thing should be equal to the chance function's probability for P sub lambda given E sub lambda. So if your total evidence is admissible, this implies that the former is equal to the latter. So your credence in P sub lambda, sorry, not your credence, the chance of P sub lambda given E sub lambda should be the chance of P sub lambda. So that's a kind of necessary condition on admissibility. And another kind of equivalent way of putting that necessary condition is to say that the chance of E sub lambda should be 100%. And my proposal is going to be to take that necessary condition on admissibility and strengthen it into a necessary and sufficient condition. So I'm going to say that some evidence E is inadmissible for the time P chances, just in case the chance function gives a probability less than 100% to E sub lambda. That's a little bit rough, but that's the idea. Let me firm it up a little bit and let me contrast the proposal I'm making with the proposal Lewis made. So Lewis said that evidence was time t inadmissible, just in case it was about times after t. The proposal that I'm making is that some evidence is inadmissible at time t, just in case there's some potential location, lambda, and some potential time t chance function, ch, such that the chance of E sub lambda, according to ch, is less than 100%. What it is for a location to be potential, by the way, and what it is for a chance function to be potential is for you to give something greater than 0% credence to that being your location and that being the objective chance function. In a slogan, the proposal is some evidence is inadmissible just in case it might be news to the objective chances, just in case you give some positive probability to that evidence that you have being news to the objective chances, or rather the locational surrogate, that information that you have being news to the objective chances. So that's my criterion of inadmissibility. And if we take that criterion of inadmissibility and we plug it back into the principle of chance deference from earlier, we get this. We're now no longer going to exclude cases where you have inadmissible information. We're going to include them and say, if your time t inadmissible evidence or information is E, then your credence in P, given that the time t objective chance function is CH, and given that you're located at lambda, should be whatever probability CH gives to the lambda surrogate of P, conditional on the lambda surrogate of E. So that's the principle that I'm going to call CD for chance deference. We've already seen how that problem solves the first, we've already seen how that proposal solves the first problem from section 2, the problem about a priori knowable contingencies. Now let me show how it solves the second problem about losing track of the time. So let's remind ourselves, you don't know whether it's Monday or Tuesday, but you know that today's chance of Mudskipper winning is 75% and yesterday's chance was 25%. Then let me introduce mu as the location it is Monday, and tau will be the location it is Tuesday. Then the first thing to note is that you have some inadmissible information in this case, not given Lewis's criterion, but given my criterion, you have some inadmissible information. The inadmissible information you have is that today's chance of Mudskipper winning is 75%. It's inadmissible for Monday. Why? Well, because tau, or it is Tuesday, is a potential location. And the tau surrogate of today's chance of Mudskipper winning is 75%. That just says that the Tuesday chance of Mudskipper winning is 75%. And that's news to the Monday chances. The Monday chances are not certain that the Tuesday chance of Mudskipper winning is 75%, whether it's Monday or Tuesday. So this is a case where you have some evidence that's inadmissible. And so the principle won't apply. It won't tell us that your credence that Mudskipper wins, given that it's Tuesday, should be 25%. And I'm not going to go through and derive it here. It's derived more carefully on the handout. But what the principle will say is that your credence that Mudskipper wins, given that it's Tuesday, should be 25%. And also that your credence that Mudskipper wins, given that it's Monday, should be, I think I misspoke, should be 75%. Whether it's Monday or Tuesday, your credence that Mudskipper wins should be 75%. So to sort of sum up, I think that the proposed principle of chance deference that put forward, it solves the two problem cases from section 1. It allows you to be certain in a priori knowable contingencies, and it gives plausible advice about how you should defer to the chances in cases where you've lost track of what time it is. And I want to take that principle and show you that it has a kind of interesting and surprising consequence for Adam Elga's Sleeping Beauty puzzle. So just to refresh everybody's memory about Sleeping Beauty, we imagine that on Sunday, some group of nefarious experimenters are going to put you to sleep with some powerful sedative, and they're going to wake you up again on Monday morning. Then on Monday evening, they're going to put you back to sleep, and they're going to flip a fair coin. If the coin lands heads, then they're just going to keep you asleep all through Tuesday, and they'll wake you up again on Wednesday and tell you our experiment is over. On the other hand, if it lands tails, then they're going to erase all your memories of having been woken up on Monday, put you to sleep. Sorry, I guess you're already asleep. They're going to erase all your memories of having been woken on Monday and wake you up again on Tuesday. So that kind of from your perspective, you won't be able to tell the difference between waking up on Monday and waking up on Tuesday. Also, you're beautiful. Important part of the case. So the big fight in Sleeping Beauty is about how confident you should be that the coin that will be flipped on Monday evening lands heads when you wake up on Monday morning. So there are two camps. There are some people who think that upon waking on Monday morning, you should be 1/3 confident that the coin lands heads. So you should spread your credence equally between the possibilities that it's Monday and the coin will land heads, it's Monday and the coin will land tails, and it's Tuesday and the coin has landed tails. That's the first camp, called thirders, for obvious reasons. And the second camp are the halfers, who think you should be 50% confident that the coin lands heads. Waking on Monday morning, you should have a credence of 50% that the coin lands heads on Monday evening. And one of the motivations for being a halfer as opposed to a thirder is that it looks like the thirder's credence, sorry, it doesn't just look like, it just is the case that the thirder's credence is departing from the known chance that the coin lands heads on Monday evening, whereas the halfer has a credence that aligns with the known chance of heads. And one way of sort of taking that and turning it into an argument for halving is by appealing to something like Lewis's principle of chance deference and showing that while the thirder is not deferring to the chances according to Lewis's principle, the halfer is. So let me just introduce some notation. So I'm going to use H for the coin lands heads. Mu is just any potential Monday location. Tau is any potential Tuesday location. And let CH just be any chance function that gives a probability of 50% to the coin landing heads. I'm going to use A for the thought that I am awake. So I am awake now. And it's important to recognize that given the criterion of inadmissibility that I introduced in the previous section, that thought that I am awake is going to count as inadmissible for Monday. The reason is that Tuesday is a potential location, so tau is a potential location. And the Monday chance function is not certain of the tau surrogate of A. So the Monday chance function is not certain that you will be awake on Tuesday. In other words, it might very well be news to the Monday chances that you are awake because it might be Tuesday. And if it's Tuesday, then I am awake expresses a thought that the Monday chances are not, or sorry, expresses a true conditional content that the Monday chances are not certain of. Okay, so A is inadmissible. Though, of course, I should just stress that the Monday surrogate of I am awake is something that the Monday chances are certain of. So if we look to the principle of chance deference that I've developed here, it'll say your credence that the coin lands heads, given the Monday chance function, and given that you're at a Monday location, should be equal to whatever probability the Monday chances give to the Monday surrogate of the coin lands heads, given the Monday surrogate of I am awake. Now, the Monday surrogate, like I just said, the chance function is certain of the Monday surrogate of I am awake. And if the chance function is certain of something, then we can ignore it whenever it shows up on the right-hand side. And also the Monday surrogate of the coin lands heads just is the coin lands heads. This is a purely de dicto thought. So the principle says that your credence that the coin lands heads, given the Monday chance function and given the location mu, should be the chance of heads. It'll say that, and the chance of heads, of course, is 50%. It'll say that not just for CH, but really for any chance function that gives a chance of 50% to the coin landing heads. So the principle of conglomerability will say that we can generalize. And it'll say that not just for mu, but it'll say it for any Monday location. And so a principle of conglomerability will tell us that your credence that the coin lands heads, given that it's Monday, should be 50%. And that, it turns out, is a pretty powerful constraint. It's inconsistent with the Haffer's favored distribution, because the Haffer says you should look like this, you should have this credence distribution. And in this distribution, your credence in heads, given that it's Monday, is 2/3, not 1/2. On the other hand, so it's inconsistent with the Haffer's position, and it's perfectly consistent with the thirder's position. The conditional on being Monday, the thirder is 50% confident that the coin lands. So I think that if you buy the principle of chance deference that I've developed here, then you should say the thirder's credence does depart from the known chance of heads. That's true, but the thirder is nevertheless showing deference to chance in the way that they ought to. They have an excuse for having a credence that departs from the known chance of heads. And the excuse is that they have some inadmissible information, namely the inadmissible information that they are awake. That's not inadmissible given Lewis's criterion, because it's not evidence which is about the future. Because in fact, we can suppose they're, or you, I guess, you're the beautiful person in this case. You're not awake on Tuesday. You could be awake on Monday. So it's not about times after Monday, but nevertheless, it's information that might be news to the Monday chances for all you know. And so it counts as inadmissible given my criterion of inadmissibility. So just to sum up, I think that sort of standard principles of chance deference face difficulties with a priori knowable contingencies like the coin lands on Api. They have difficulty about how to show deference to chance when you know things or when you have credence and thoughts about what the current chances are and you've lost track of what time it is. And I proposed a revision to fix those problems. I did that by defining the notion of a locational surrogate for a thought given a location. And I proposed that we should modify, in general, principles of expert deference to say that you shouldn't defer to experts about your thoughts, but you should instead defer to them about the locational surrogates of your thoughts, given your location. And when we take that principle and we apply it in the case of chance, it'll say that you should be 100% confident in a priori knowable contingencies. And it'll give sensible advice in cases where you have credence in thoughts about what the current chances are, but you've lost track of what time it is. It turns out to be consistent with the thirder's solution to Sleeping Beauty, but it's not consistent with the Haffer solution. Okay, and that's all that I have to say for myself. Thanks for listening.